Welcome back. So I'm going to create a new class called Review of Arithmetic Operators. Okay, and so this a little bit of a long name for the class, but I'm going to first create the class header, Review of Arithmetic operators. Okay, and then we're going to create the main method header. Okay, I'll say at this point too, if you are if you're at this video, you don't feel the need to create this similar class and then keep pausing the video and typing all the code down. You can just sit back and watch this video as many times as you want to. You can definitely pause and rewind if I went through something too fast. You can even ask me at any time if you have any questions about any material. But maybe just watch and learn, and then I will give you a series of exercises to test your knowledge. Okay, so hopefully that will work out for you. Okay, so in this class, I'm going to just talk about all of the arithmetic operators or the mathematical operators that you should know about so far. We learned about them in last year's course, and you should definitely know about them in this course. But quickly before I do that, something I wanted to mention last class, but I forgot to, or in the last video. If I have an integer variable, I'm just going to call it x. All right, you are allowed to just put a semicolon there. Now that does nothing. If I run the program, nothing happens, nothing is printed. Actually, I lied. Something does happen. This variable is created in RAM, but we're just not putting anything in there. So you could say x is assigned 5, and then you could print x. Okay, and then that will just print 5. But normally we just put this all on one statement, and we do both at the same time. So we create the variable and we assign it a value at the same time. But you can do that in 2 different steps. All right, so this should compile okay with no errors. Yeah. Now, one thing I wanted to mention is that if I put a decimal here, like 5.3, and compile, then that is not going to work. Okay, we saw this in the last video, but we were using the scanner class to input values. Here, I'm not using. Notice I'm not using the scanner class at all. You don't always have to use the scanner class, and if you don't have any user input, then you don't need it. So, but I'm just illustrating that you cannot put a double value into an int. You would have to change this to a double variable for this to work. Now, can I change this to an int? Yes, you can. So this actually works. You can put an int into a double variable, but you can't go the other way around. You can't put a double into an int variable. Okay. Notice when I run this, it prints 5.0. Okay, because when I put this integer 5, when I put this into the double, it automatically converts it to a double value. Okay, and then of course, if this was a let's say a string. So if I declared this to be a string variable, then you could not do something like this. You would have to make this a string. Okay, so that would work, or you could put names in there. So you can put names. So that does work. If I made x, if I declared it as a char variable, then this will not work. You can only put a single char. Okay, so something like p. So that would work. Oh, actually, sorry. Chars, you must use single quotes for char data, and then double quotes for string data. So that would work. Okay, or I could put the $, something like that. All right, no problem. You can even put a number in. So if I put 65, let's say, that actually works. And when I run it, you'll notice you get the letter A. And if you remember from last year, this is called an Ascii code. So that's the American Standard Code for Information Interchange. So 65 just happens to represent capital A, 66 is capital B, and so on. Okay, so again, a review from last year. Oh, and then there's another type of character and it's called an escape character. So if I put something like backslash t, okay, that is called an escape character, and that's basically like the tab character on your keyboard. So that represents a single tab. Backslash n is a new line. So that's kind of like pressing the enter key on your keyboard, or the return key. There's another one, backslash. So if you have two backslashes, that just records a single backslash. So this actually works because it's a special character called an escape character, and when I run it, it actually just prints a single backslash. And then the other one that you should know about is backslash double quote. So that's how you store a set of double quotes into a variable. So you can see that this will print just a simple set of double quotes. Okay, so I thought I'd throw that in there before we go and talk about arithmetic operators. So if, well, addition, pretty straightforward. If I say 2 plus 3.5, okay, so that's going to do, it does the arithmetic. So the compiler will actually do the arithmetic first and get the answer, and then it will print it. So that should say 5.5. No problem. What if I did letters? Like what if I said A plus B, like two characters? Does this work? Interesting. No errors. And if I run it, okay, so you don't get C as your answer. You get 131, and you can kind of guess what's happening here. It's actually changing these to ASCII values, so 65 plus 66, and it's adding those two together. Okay, what about strings? Like what if I said dog plus cat? Well, that works as well, but it does not add ASCII characters. It literally just concatenates those two strings together. So it just joins them together. So you got to be careful. The plus sign could mean arithmetic, but it could also mean concatenation, where it joins two strings together. Okay? Now, subtraction. So if I just said 5 minus 7, okay, that will work, and it will print -2. There we go. Now, what if I subtracted two chars? A minus C, let's say. Okay, it works, no errors. And if I run it, you might have guessed, it's going to give you -2 also. So that's because A is 65 and C is 67. So it's subtracting those ASCII values. What about strings? So could I do dog minus cat? And you may remember from last year that this crashes. So you know you cannot subtract strings at all. Okay, so I'm just going to get rid of this line completely. All right, so addition and subtraction, pretty straightforward. Multiplication is also straightforward, so something like 3 times 5. So that's going to give you 15. All right, no problem. You cannot multiply characters or strings. All right, I'll just save you the time there and tell you that. Now, division is the one where you got to be careful. Okay, and many pieces of software, even large operating systems, like I think it was Windows 95, if I'm not mistaken, crashed on the day of release because somebody divided. And I think they divided by 0, and it gave an error somewhere deep in the code, and it crashed the whole system. So you really got to be careful with division. So I'll show you what I mean here. If I say 1 divided by 2, so from math class we all know that that is 0.5. But if you do this in Java, it gives you 0. And what it does is it just throws away the decimal place. It doesn't round, it just throws away or truncates the decimal. So if I wanted to keep the decimal, remember you have to either make the first operand a double, or you could make the second operand a double. Okay, the operand is just a fancy word for the numbers on either side of the operator. So that's the operator, and these are the operands. So now, if one of these things, or if both of them, is a double, then it will keep that decimal. Okay, so you just have to really be careful about that when you're doing division. If you, I mentioned dividing by 0 earlier, so if I did like 3 divided by 0, so notice you don't get any syntax errors, but watch what happens when I run it. Okay, it crashed, and it tells you you have a division by 0 error. So this is one of these difficult errors where you think everything is fine and dandy because you have no syntax errors, but then when you run your program, it crashes because the computer can't divide by 0. Now, if you change that to 0.0, then all of a sudden everything works, and it gives you infinity. So that's a built-in command that Java gives us, which I don't really love that they did this. I kind of wish that it said undefined, because that's the true answer. If you take a number and divide by 0, it's not infinity. If this was 0.000001, then yes, this number will be really big. It'll be close to infinity. Well, it won't be close to infinity, but it'll be a very, very large number. And the closer that this gets to 0, the closer that this quotient will approach infinity. So I think that's why they put infinity in there. Okay, so just watch out for when you're dividing by 0. And again, it's rare that you would ever code this in a program. I mean, all of this stuff really, it doesn't really make sense as a useful computer program. I'm just illustrating to you the different arithmetic operators. So usually you have to be careful when you are asking the user to enter two numbers. And if you're doing a division on those two numbers, you have to make sure that they don't enter a 0 for the denominator. All right, so you can use if statements and things like that to help out. Okay, so another math operator that we learned about last year was modulus. So I wonder if you remember what 17 mod 5 is. So if I run this, you get an answer of 2. Okay, so what is the modulus operator? Let me close this. Well, basically it takes the remainder after you divide. So it takes 17 divided by 5, and then it gives you the remainder. I like to think of it this way. How many 5s fit into 17? So how many 5s can you fit into 17? Well, 3. 5 times 3 is 15. And then you take whatever's left over. So 17 minus 15 is 2. All right, let's try another one. If I do, let's say 15 mod 6. Okay, well, how many times does 6 go into 15? Only twice, right? 6 times 2 is 12. And then 15 minus 12, the remainder is going to be 3. So you should get an answer of 3 here. And we do. Good. What if I did 560 mod 2? Okay, sounds like it might be a hard one to do, but it's actually pretty simple. So what is the remainder if you took this and divided by 2? Well, you'll see that this is an even number. So if you divide it by 2, it's going to fit in evenly, and you should have a remainder of 0. And that's what we get. We get 0 as the remainder. But if I change this to 567, let's say this is an odd number, then that means the remainder is going to be 1 when I use the modulus operator. Okay? All right, so hopefully modulus makes sense. And then there are other commands like math.pi. It's not really an operator. That's called a mathematical constant. So this is a built-in constant built into the Java language. So if I run this and print it, you can see that you get pi equivalent to, I believe it's 15 decimal places. Okay. And then there are also built-in math methods, so like pow. So you could do 2 to the power of 10. okay, which should be 2 to the power of 10 is 1024. And if you compile it and run it, you get 1024.0. So it gives you the right answer, but it always gives you the answer as a double value. All right. There's another one you should know about, and that is square root. So if you ever want to take the square root, you're going to say SQRT, and then inside the brackets you put the number that you want to take the square root of. So this is going to take the square root of 16, which is 4, but it gives you the answer as a double value. So it gives you 4.0. Okay, so I think that's it for now in terms of arithmetic operators. Again, this is just a demo of all the different operators and things that you have to be careful with. Of course, the real programs that we write will involve user input and kind of more elaborate calculations. And so that's all I'm going to say. Actually, wait, one more thing I should talk about is the order of operations, like bed mass. So you all learned about bed mass when you were in middle school, hopefully, or you learned, some of you call it ped mass. But B stands for brackets, and then exponents, division, multiplication, addition, and subtraction. So that again, that holds true with Java programming. So we always do brackets first, or parentheses, you may call them. Exponents, yeah, exponents come next. So if you had to do the POW, then that would come next. Division and multiplication, now that's actually a tie. So they are the same importance. It just goes from left to right. So for instance, if I had like 5 times 3 divided by 2, they both have the same importance, the same level of precedence. So that means we would the compiler would just go from left to right. So it would do this first, and then it would divide by 2. Now, where does modulus fit into this whole mess? So what if I had like something like this? Well, it turns out modulus is right in here. So modulus happens in between division and multiplication and addition and subtraction. So we're basically going to do this stuff first. So we're going to do multiplication, then division, and then we do modulus, and then we're going to do addition and subtraction. I guess it would be more exciting if I shuffled these around. So if I did something like 7 plus 3 mod 2 times 5 divided by 2. Okay, so what would happen first? Well, the compiler would first do this, 2 times 5, which is 10. And then it would do 10 divided by 2, so it would do the division next. And then it would do the modulus next. So it would do 3 mod whatever this works out to be, which is 5. And then it would do addition last. Okay, so you do have to know this order of operation, and basically you just need to know that the modulus happens before addition and subtraction. Okay, if there's any questions at all, feel free to ask me either in class or send me a quick email, and I'd be happy to help. Okay, so thanks for watching, and we'll see you in the next one.